All right. So, like we said, if each one of these is a tenth, and then the next number, that'd be 3 and 1/10, 3 and 2/10, 3 and 3 and 3/10, 3 and 4/10, 3 and 5/10, 3 and 6/10, 3 and 7/10, 3 and 8/10, 3 and 9/10, and then 4. 12 and 4/10 would be right there. 3 and 1/10 would be right there. So we're closer to 3, and we're closer to 12 than we are to 13. So, let's see if they do the same thing that we did. Yeah, they did. Cool. And then they did 12 times 3, which we did over here. 12 times 3 equals 36. And then they actually did the real math, so let's do the real math as well. 1 times 4 is 4. 1 times 2 is 2. 1 times 1 is 1. Second line, ones place, 0. 3 times 4 is 12. Carry the 1. 3 times 2 is 6, plus 1 is 7. 3 times 1 is 3. Add it all up. So we get 3,844, but we also need to remember there are decimal places in our problem. There are 2 decimal places in our problem, so there should be 2 decimal places in our product. And we matched our answer with them, which is 38 and 44 hundredths, which is very close to 36. All right, so, oops. That did help us find out if that was reasonable. Let's move on to the next one. Let me actually clear the screen. All right, and then let's check it out. So I have 1 and 7/10 and 3 and 2/10. All right, and they want us to estimate the product. Okay, so on this one we have 1 and 7/10 times 3 and 2/10. Like last time we had a number that had a tens place. This time we have 2 numbers that don't even have a tens place. So we're probably rounding just to the nearest whole number. So 1 and 7/10 is about 2. 3 and 2/10 is about 3. Remember, the way that we know that is if this is 1 and this is 2, and this is 1 and 5/10, that means 1 and 7/10 is around here, which is closer to 2. If we're looking at 3 and 2/10 between 3 and 4, if this is 3 and 5/10 in the middle, 3 and 2/10 is somewhere around here, which is closer to 3. Oh, missed that one completely. All right, so they're going to show us the same thing. So here's the numbers between 1 and 2 for 1 and 7/10, between 3 and 4 for 3 and 2/10. 1 and 7/10 should fall on the 7/10 line. So here's 1, 1 and 1/10, 1 and 2/10, 1 and 3/10, 1 and 4/10, 1 and 5/10, 1 and 6/10, 1 and 7/10, way closer to 2. And then 3 and 2/10 would be 3 and 1/10, 3 and 2/10 right there. Once again, closer to 3. So we're looking at 1 and 7/10 is closer to 2, 3 and 2/10 is closer to 3. So we're looking at 2 times 3. 2 times 3 gives us 6. So our estimate is 6. All right. Now, if we're actually going to do the math, we can do 1 and 7/10 times 3 and 2/10. They just happen to line up. 2 times 7 is 14. Carry the 1. 2 times 1 is 2, plus 1 is 3. Second line, ones place, 0. 3 times 7 is 21. 3 times 1 is 3, plus 2 is 5. And we add that all together. We have 2 decimal places in our problem. We need 2 decimal places in our solution. So our answer should be around 6, we said, with the estimation. It's not even that far off with 5 and 44 hundredths. So, oops. What did Mr. Johnson do incorrectly? He did some math wrong. Let's check. 2 times 7 is 14. Carry the 1. 2 times 1 is 2. Plus 1 is 3. Cool. Second line, 1 plus 0. 3 times 7 is 21. Cool. Carry the 2. 3 times 1 is 3. Plus 2 is 5. Did he make a mistake? I don't think he did. I think they did. So, we're close. They're close. We're right. I don't think they're right. So if you can, for fun, check the work. See if you get the same answer as me or as them, even though all of our digits were the same. That's fun. All right, we got one more when we come back. So come back.